Okay class, so we continue with the next video. Here is next objective. Okay, objective number 3 and objective number 4. So objective number 3, if you read again, is about the least square method. Okay, so simple linear regression. Okay, simple linear regression. So we have a method that we call as least square. Okay, least square method. So least square method or regression. So if you see the word of least square or regression, so that's mean the same thing, which is least square method. So least square regression line is given by y head equal to a plus bx. So actually this equation is what we call is familiar to you. Okay, this equation is linear equation, which is y equal to mx plus c. We learned this before in secondary or in school. Okay, mx plus c. So basically it's the same thing, just it's used a different alphabet, that's all. But the meaning or the what we call it, the meaning of alphabet actually is the same thing. For example, here m is equivalent to b. Okay, so you can see b is a coefficient for x, right? So same as m. So m here actually is a gradient. Okay, gradient. And c here is a intersection. So the same thing. A, so just the usage of alphabet, that's all. Okay, alright. So to get b, okay, yeah, but we didn't use the normal practice like we learned before in school, that how we find the slope or gradient. In this chapter we find b by using this formula. Okay, and a we just find by using this formula. So y, okay, is different. Okay, if you can see here, this is y head and this is y bar. So y bar and x bar actually is mean. Okay, this is what we learned before. X bar is mean for x, because we have two data, is it? We have x data and we have y data. So you need to find the mean for x and also the mean for y. And then you substitute here. So to get your a, basically you need to find your b first. Okay, so this is a formula for b, and yeah, it's easier for you to get these two terms, is it? I already showed it in the previous video. So yeah, that's all. So it's simple. Okay, it's just simple equation. So alright, so now we go to the objective number 4. Okay, which is the last one, which is making inferences about the slope. Actually, class inferences, if you still remember, we already learned it before in chapter 6, chapter 7, and also chapter 8. But chapter 8 is about two population. So the basic one here is chapter 6 and chapter 7, which is estimation and also hypothesis testing. So yeah, we are still in this area, which is estimation, but now it's not estimation of mean. Okay, if you still remember, before we learned about estimation of mean, estimation of proportion, is it? But now it's estimation of slope. Okay, it's slope b. So we go first for estimation. So it's similar, which is we have to point estimate and also interval estimate. Okay, so for point estimate, this is the equation that we use. And for b, for interval estimate, this equation that we use. Okay, b plus minus t alpha over 2 sb. So for this case, or for this chapter, they have no large sample, they have no small sample. We use t. Okay, it's not z, we use t table, and the degree of freedom of it is n minus 2. It's not n minus 1, it's n minus 2. And class for SB here is given by these two formula. Why I said two? Because this is SB, this is the equation for SB, and inside this you need to find your SE. So, and this is the equation of SE. So meaning that you need to find your SE here. Okay, and after you get the value for SE, you substitute back here, and then you solve it, so you get SB. Then you will substitute here. So it's quite longest step lah. I mean, they have a few steps that you need to calculate first before you can get the SB. Okay, alright. So class, yeah, basically for this video I just explained the direct forward lah the equation or what we use and so on lah. Okay, they have no example on this video. Okay, so next is hypothesis testing class. So it's same thing, we have to, which is a null hypothesis and also alternative hypothesis. So for the hypothesis we use H naught and it must be equal. So it's same concept. Okay, tak ada beza. I mean they have no difference between the previous chapter. So it's same, but the difference is slope. It's not mean, it's not proportion. That's all. So okay, they have not here when the null hypothesis is not rejected, which is we accept lah. In other words, when we accept the null hypothesis, the conclusion is that there is no significant relation. So when we every time we accept H naught, that means the conclusion that we can make here is they have no significant relation, no significant linear relationship. Okay. Okay, so the same thing. So we have the cases where it's left-sided, right-sided. Okay, left-sided is less than, right-sided is greater than, and also two-sided. Okay, so the same thing. And then also this is the equation for your test statistic. So you still remember we have a few steps. So the first steps is you need to state the null and also the alternative hypothesis. Then we need to calculate the test statistic. Okay, T equal to B minus capital B over SB. So where is your capital B come from? Capital B here come from your null hypothesis. So usually lah, sometimes yeah, they have numbers other than 0, but usually it's given to you 0. Okay, so you just replace lah, your B here is 0. Okay, alright. Okay, so yeah, they have no video for example because everybody already yeah, maybe you can refer your textbook, because if I upload the example, nobody want to watch my example. So class with the I mean this is the end of this chapter, and also it's the end of our classes or lecture. So that's all from me, and thank you. Bye.